Hi, this is Nalini Elkins with Industry Network Technology Council. If somebody can send me a quick note and to let me know that you're hearing me okay, we'll go ahead and get started. As always, we are recording this webinar. A little introduction. I think most of you have attended many of these sessions, but for some of you who are new, this is a collaborative project with two different nonprofits. One in the United States, the Industry Network Technology Council, and the India Internet Engineering Society, again, a nonprofit in India. Our funding for this set of webinars is a grant from IIESoc Asia, which is a project of APNIC Foundation. Thank you very much. And we have had, of course, as many of you know, funding from Aaron as well. And in fact, we are very soon going to be telling you about our analysis of security and application conversion, which has been the main focus of our endeavor with Aaron for this past year. And of course, what we'd like to see is IPv6 deployment at enterprises. This is a multi-year project. It's going to take everybody a while. And so we've covered various aspects of this. To that end, what we have done is done quite a few classes till now. And we are to the portion where we are talking about IPv6 and cloud. These next couple of sessions will likely be a little bit different than what you guys are used to, where we do first a theoretical session, and then we do a hands-on lab. For example, in this one, we will have presenters from Oracle who will do both the theoretical and as well as the lab session for their offering. Do feel free to ask questions throughout. I will be directing them to the presenters at the end. So a few words about me, and I'll keep this very short because most of you have heard this little thing quite a few years. I am the president of INTC, and I also have a for-profit company of which I'm the founder and CEO. I'm on the advisory board of the IIESoc, and RFC 8250, among others, is one of my RFCs, which we are enhancing at this very minute. And if anybody is interested, do please let me know. I am basically a coder, and that's what I do, is I develop products. I've been working with IPv6 for at least 15 years. It seems like my entire life, but it's something that I'm very passionate about and love. And so let me introduce you to Shireen and Ajay from Oracle. We are very lucky to have Shireen and Ajay from Oracle presenting with us. And Shireen is a product manager in, as you see, OCI Virtual Networking. She knows a lot about IPv6 and other key initiatives. She's done a lot of product management at various areas, all in the cloud area. And as I say, this is a tough area to get your hands around. And she's very, very focused on trying to meet the customer needs. So do direct lots of questions to her and as well as Ajay. Ajay will be doing the lab portion. He has a lot of deep engineering experience, including working in software-defined networking, which will be very tricky to see how we're going to pull all that off with all this virtualization and cloud and everything else. I know it makes your life very complicated, and so do ask Ajay, as he has quite a bit of background in that. He's been a major contributor to a number of the open source projects, as well as a featured speaker to various workshops. And so, as I say, we're very lucky to have both of them. Let me go ahead now and turn this over to Shireen first, and she will give you the theoretical background of the whole cloud area. So, Shireen, I have made you presenter now.
Okay, thank you so much, Nalini.
No, my pleasure. Thank you for speaking.
And let's see. Just need to switch monitors here.
We're seeing your.
Oops. Are you seeing the safe harbor statement?
Yes, we are. We're seeing that perfectly.
Perfect. So I just need to get a little bit of housekeeping, completed before I jump into the content for today's presentation. But first, I just wanted to thank you, Nalini, for reaching out to Ajay and myself. We are happy to participate in this webinar this morning. So a couple things. Just want to give the audience a couple of minutes or a minute to read our safe harbor statement. Essentially, just protecting us that this is general product direction. Essentially, don't necessarily hold us to if we were to talk about any dates or commitments or things of that nature, which I don't intend to do. And as Nalini expressed earlier, we are going to be recording the presentation. So just want to make sure that all of the attendees acknowledge that. And we also do have policies that we have to adhere to for that, which we've already addressed. So Nalini's already done a very gracious introduction for both myself and my colleague Ajay. So I will skip over this. And this is the agenda that we plan to cover for today. So first, I wanted to give a brief overview into Oracle Cloud Infrastructure Networking, just because each of the clouds do have their own nomenclature, their own constructs for virtual networking. So just want to make sure we have a baseline before we dive into specifically our support for IPv6. I then plan to cover a few scenarios in terms of connectivity and communication that customers are going to be interested in as far as leveraging IPv6. And then I'll hand things over to Ajay, where he will walk you through a live demo within the Oracle Cloud Console. So IPv6 is a protocol that we have enabled in many of our networking services. So this slide is intended as an overview of network elements and related resource configurations in Oracle Cloud. As you can see, the top of the networking hierarchy is a virtual private network. In Oracle, we refer to these as virtual cloud networks, or VCNs. Within VCNs, customers will have subnets, security lists or network security groups, and gateways. And similar to any network, customers would need to configure routing and specify security rules. We also provide a network visualizer, which is what you'll see in the top right-hand corner of the slide. And this is intended to help users obtain a graphical topology of their deployed networks, how the resources are related via routing, and provide easy navigation to route tables and security lists. In terms of protecting customer networks, Oracle supports 3 distinct dimensions through which you may enforce your security policies. So the first is through subnets. So we support a subnet level attribute wherein subnets can either allow or prohibit internet communication. So for example, customers may want to set up a subnet as a DMZ if you're using a load balancer or a firewall with a trusted and untrusted side, deploy web applications on a server in a public subnet so you can allow direct access from global internet customers, or host sensitive data on databases in private subnets. The second dimension is through gateways. gateways control connectivity between VCNs and resources hosted in other VCNs, resources hosted on the internet, or resources hosted in customer on-premises networks. NAT gateways are leveraged to facilitate IPv4 connectivity between the internet and private subnets. Service gateway facilitates connectivity to public OCI services that's hosted on our Oracle Services Network. And the dynamic routing gateway supports connectivity to on-premises networks or other VCNs via peering. Internet gateway, as the name implies, provides internet connectivity to resources hosted in public subnets. Finally, the third dimension is security rules for security lists or access control lists, ACLs, or another terminology for that, or network security groups. The distinction here is that security lists are on a per subnet basis, while NSGs cover a group of instance VNICs that may span multiple subnets. So here's where we get into the meat of what we're focusing on today, our support for IPv6. So Oracle announced general availability of IPv6 in Oracle Cloud in April of this year for all commercial and US government regions. Ours is a dual stack IPv4, IPv6 implementation, which allows for both progressive expansion of IPv6 compatibility in our cloud, as well as backwards compatibility. Both our public sector and commercial customers have expressed the need for both as they transition to IPv6. Customers can optionally enable IPv6 in their VCNs, and we will allocate a /56 internet routable CIDR for each VCN. Within IPv6 enabled VCNs, customers can optionally enable IPv6 on a per subnet basis, which will be a /64. Each VCN given a /56 supports roughly 250 IPv6 subnets. Each subnet can be specified as public or private, as I previously expressed. And if a subnet is specified as private, even though the CIDR is inherently internet routable, we will provide a control plane enforcement that prohibits internet communication with IPv6 enabled resources deployed in the subnet. Compute instance VNICs and load balancers can be assigned an IPv6 address from their subnet CIDR, and we will vend the address to the instance operating system via DHCP v6. Connectivity from on-premise networks such as Fast Connect and VPN can now also be IPv6 compatible. And we support north-south and east-west IPv6 communication. So let's take a closer look at that. So first I'm going to talk about east-west. So this is an Oracle Cloud region. This could be Mumbai, this could be Tokyo. We have lots of regions that we've deployed globally. And as you can see, this is a VCN, which you'll note has both a /16 v4 CIDR as well as the /56 that I mentioned earlier. So here we have two subnets, subnet A and subnet D, and you'll notice here that both of the subnets have also been enabled for IPv6 along with their IPv4 CIDR. But subnet B and subnet C are only IPv4. So customers have a choice. They don't have to enable IPv6 in all of their subnets if they don't need to. So here we have deployed a few resources, virtual machines, load balancer, and a database system. And each of these resources will be assigned an IP. And that's just indicating that we will vend the IPv6 address to the virtual machine VNICs via the DHCP. And in this case for east-west, typically we're talking about private connectivity. So we're talking about connectivity between customers' private networks that they've deployed in Oracle. And this could also span local peering gateways to a locally peered VCN. So that's just giving you an example of the route table, route rule that you could leverage to communicate between the virtual machine in subnet A and the virtual machine that is in the locally peered VCN. So as I mentioned earlier, ours is a dual stack IPv4, IPv6 deployment. And part of that is because we contend with some of the same challenges that our enterprise customers and public sector customers talk about, which is that we don't want what's currently working to break. So we have to do this in a progressive manner. So our load balancer story is just an example of this that I wanted to highlight. So in this particular slide, you can see that you've got a client request, coming from the internet or from anywhere really. But in this case, there's a load balancer that's sitting in front of a backend set. So the load balancer listener in this case has been enabled with IPv6. So that's why you see dual stack at the compute instance, you see dual stack at the load balancer from the listener perspective. But the backend communication today still remains over IPv4. Now, as an organization, we are progressively enabling more and more of our services to be IPv6 compatible, but we can't get everything day one. So this is just illustrating an example of a dual stack communication path. And so now we move over to a north-south scenario for communication. So much of this diagram looks similar to what we had shown before for east-west, with a few distinctions. So first, you'll notice that in the previous example, subnet A and subnet D were private. But in this example, now these subnets have been specified to be public. And what that means is we now can permit internet communication via the internet gateway. We also want to show connectivity to customer on-premise networks. So on the left, you'll see an example of a customer data center. They could connect via Fast Connect or VPN. And those connections terminate on a dynamic routing gateway. And we can facilitate IPv6 communication over the Fast Connect and the VPN. And we can also support IPv6 communication for remote peering. So in this example, it's a little bit distinct from the east-west example because in this case, the peered VCN is actually in a separate region, and that is why the routing would take place via the dynamic routing gateway. So on the left, we just have some examples, of routes, IPv6 routes that we would include in the route table to facilitate the internet connectivity as well as the connectivity to the on-premise network. So with that, I'm going to be turning things over to my colleague Ajay, where he will be walking us through a demonstration of the scenarios that I just showed.
Great. Thank you. Thank you so much, Shireen. Let me make Ajay presenter. So that will take me one moment. All righty. Ajay, so you are now presenter. One question we had, Shireen, while he's coming on, which was very quick.
Quicker than me.
Certainly quicker than me, I'll tell you that much. So the question is that you mentioned that subnets can be dual stack and they can be IPv4 only. And now take a deep breath, but can they be IPv6 only as well?
Not today. So today it's either IPv4 only or dual stack. That's our support model today.
Sure. And I think it's a little, that's great to know. And it's a little bit ahead of, I mean, down the road, I think everybody wishes to be V6 only, but it's going to be a little bit. So thank you so much. Ajay, you're on.
Awesome. Thank you, Nalini and Shireen. Can you just confirm that you're able to see my screen?
Yes, we see your screen perfectly, and we hear you very well as well.
Okay, awesome. Thank you. And before I get started, I just wanted to make one round of question, like if there's any question right now before I get started, or if there are any questions related to Shireen's slide deck, feel free to ask right now, or as I keep doing the demonstration, feel free to interrupt me at any point of time. Okay, with that silence, I'll get started. So this is the home page of the Oracle Cloud Console. So whenever someone logs in into OCI, sorry, somebody had a question?
I'm going to interrupt you just for a second because I'm getting a couple of people saying
Okay.
that they can't see your screen.
Okay.
All right, so hold on for a moment and let me do this again. Okay, so I'm going to go ahead and take control back to myself, and then because I don't want people to not see what you're doing. Okay. All right. So guys, maybe you can send me a quick note to say that you're seeing my screen. Okay, yeah, okay, all right. So guys, you can see my screen. Now we'll start over. Okay. So Ajay, I'm gonna make you presenter. Okay. Okay, guys, can you see Ajay's screen now? Maybe just send me a quick note. Perfect. Okay. Sorry to interrupt, Ajay. I just wanted to.
No.
Oh dear. Okay. Hold on. Some people are still not seeing his screen. Okay, we need to. Oh boy. Yeah, as I say, I want to. But it says waiting to view Shireen. All right, one moment. Sorry, guys. Let me take Shireen. Okay, let me make her an organ. Look, sorry, I just want to make sure people can see your screen, obviously. Okay, because as I say, some people are seeing it and some people are not. Okay. All right, so some of the guys, some of the people who were not seeing, oh, perfect. All right, so everybody is seeing your screen now. Sorry for this, Ajay, but I just wanted to make sure everybody was seeing you. Okay, all righty, so thank you so much.
Okay, so am I still sharing it? Because I don't see that window of sharing.
I believe you are. You're organizer and presenter, and
okay.
So I think, yeah, but we're seeing your screen just fine. I'll let you know if something happens.
Okay, sounds good. Thank you. So, so I was about to so this is the home page of the Oracle Cloud Console. So whenever somebody decides to migrate their application or any sort of services into Oracle Cloud, this is the first page they would hop onto. So as a networking, so when you want to go with the networking, I'll just click on the sandwich button on the top left and take you to the networking piece. So in the networking section, the first thing that we want to do when you are working in Oracle Cloud is to configure a virtual cloud network. So think of virtual cloud network as a construct where you define the CIDR ranges, where you define the constructs that you want to configure for your particular network. So when you come onto this VCN page, you either have an option to create a VCN manually, or we also provide an option to do it with a wizard. And when you select a wizard, it gives you an option whether you want to go with the internet connectivity or you want to have it like VPN connectivity from on-premises to the Oracle Cloud. The difference between the two would be that it would configure different gateways for you. So for the internet, it will configure internet gateway, NAT gateway, service gateway, and as Shireen showed you that these gateways are used to either communicate to the internet or to the Oracle Services Network from the VCN. So within the VCN, whatever OCI, whatever resources that you create in OCI will be tied or will be associated with this particular VCN, specifically to the subnet that you configure. So say, for example, when you create any resource, there will be a VNIC created for that particular OCI resources, but the IP address that it takes comes from the subnet, whether it be an IPv4 address or whether it be an IPv6 address. So having said that, I'll go ahead and create a VCN. I'll do it manually, and the first thing that we'll do is we'll give it a name. So I'll give it a name, and then like Shireen mentioned, we support today a dual stack IPv4 IPv6. So we don't have an only IPv6 only support today. So we have to mandatorily provide an IPv4 address. So I'll go ahead and give us IPv4 CIDR. And the next step here is where it gives an option to enable the IPv6 CIDR block for an existing VCN. So I'll go ahead and select this particular option. And as you can see, it did not ask me to provide any sort of EULA ranges or any sort of CIDR blocks for this particular IPv6 range, because Oracle would automatically assign a /56 block for me, which will be more of a GUA addressing. And then the user has an option to configure the DNS host names or the label they want to. So these are the minimum set of steps that you want to do to enable IPv4 and v6 for your existing VCN. So I'll go ahead and create a VCN. So as you can see, when I created a VCN, it gave me this /56 CIDR block to my particular VCN. Now the next thing what we want to do is we want to create a subnet, and we'll follow the same steps. So I'll just give it a name, public subnet, and then the user has an option to either select like a regional based subnet or an AD specific subnet. So regional subnet meaning that this subnet in a multi-AD region will be spun up across all the ADs, all the availability domains that is there in a particular region. So say, for example, in Ashburn, we have 3 ADs compared to other single AD regions like Mumbai. So it will be spun across AD1, AD2, and AD3. But if the user wants it to be specific to a particular AD, they can choose to go with this particular option. But for this demo, I'll just go with the regional ones. And before I get ahead, like if I select AD specific, it will give me an option which ADs I want to select. But if I don't, if I go for the regional, it will be my subnet will be across the entire ADs. So then I will probably give the v4 CIDR block as it is mandatory. I cannot skip this step. And then the user has an option to either enable v6 for this particular subnet, or they can choose to not enable it. It's an optional field, and we support both today. But for demo purpose, I will go ahead and select it. So once I do that, it prompts me to provide the last 2 hex characters, and it will automatically create a /64 subnet for me because it's the standard practice to do that. And as you can see, it took these hexadecimal bits from the VCN range that was automatically created. And when that VCN was created, the last 2 hex bits will always be 00, because once you start creating a subnet, it will give you an option to do further subnetting or to select the last 2 bits either from 00 to FF. So what I'll do is I'll just, for the demo, I'll select 01, and then it will ask me to select a routing table for this particular subnet. Every subnet has a route table associated with it. So I'll go ahead and select the default route table. And then like Shireen was mentioning, that if you select a private subnet, and even if you have a route to the internet in the route table rules for IPv6, you will not be able to access the internet because we prohibit internet access at the subnet level. So as you saw that we got an IPv6 address range from a GUA CIDR block, not a EULA range. So that is where, like, if you spin up an OCI resource from a public subnet, you will be able to access the internet, of course, provided that you have that route to the internet gateway in your routing table. But if you do that same exercise in the private subnet, even if you have the route table role and everything is configured same, you will not be able to access internet. So for this demo, we'll select the public subnet, and then the remaining pieces is an optional field. You can decide to keep it as it is. And the most important piece is the security list rule here. So security list basically is something that is required to make sure that whatever traffic is coming in and out of your VCN is controlled. So you can control that traffic. Say, for example, you can only allow ICMP traffic for any resources configured in this particular subnet, for example, or you can allow only SSH traffic to pass through this particular subnet. And I'll be showing you guys an example in the next step. So before that, I'll just go ahead and create a subnet. So let's give it a moment. It should take some time to be available. And as you can see, we were able to successfully create a subnet, a public subnet, which is a public subnet which is having public level access, and the state is available. The CIDR block is the one that I defined, and the V6 CIDR block is almost the same that we had through VCN, but the only last 2 hexabits was the one that I had manually changed. So I'll pause here for a second to see if there are any questions before I move ahead.
Ajay, we're not seeing. I'm not seeing questions from the audience, and I have one, which is maybe a bit pedantic. Is you know, I mean, as far as I'm thinking, I associate CIDR with and subnet masking with V4. So it's kind of curious that you guys use that terminology. I mean, I know what you're saying.
Okay,
but
this
anyway.
one, right? So
yeah. When you say, well, no. When you say IPv6 CIDR block, because anyway, as I say, it's a bit pedantic and maybe it's kind of distracting. But I think you mean IPv6 prefix.
That's correct.
Yeah. So anyway, now as I say, we can move on. I don't mean to be all bogged down in words.
No, that's totally fine. We always welcome feedbacks. So if there's something that is not according to the standard, or it's been not used the way you guys discuss or talk IPv6, probably we are happy to take any sort of feedback. And
yeah, I was just gonna say, Nalini, that's really interesting. So as part of the productization effort for IPv6, we sort of had to balance this idea of making the experience from user experience perspective as far as configuring and provisioning networks in Oracle consistent, but then also, of course, acknowledging and honoring IPv6 as being distinct. So that is, I think that is an interesting feedback. I haven't actually heard that yet from any of our customers, but I'm sure, from a specificity perspective and an accuracy perspective, it is more accurate to say prefix. So I'll put some thought into that as to whether or not that would it cause more confusion, or would it actually help customers as they make this transition? Just because from a provisioning standpoint, it is quite similar from a step-by-step process as the IPv4, but I do hear what you're saying, that it's technically not a CIDR. So good feedback.
Yeah, thanks. And I'm getting a couple of, people backing me too. And I think, as I say, I am, and quite a few people on this call, we're IETF nerds. And so that's when our hackles go up.
No, that's
and
but
I totally hear what you guys are saying, because one of the other things that we've done too, and that we've been preaching, is don't do IPv4 thinking in IPv6. So our people are maybe a little more indoctrinated in this. We definitely, I don't want to, because you guys are doing such great, we can go through and we can have an offline discussion. We would love to have that with you guys. And so we can kind of give you our spiel on, how not to, bring IPv4 paradigm into v6 to fully use it. But let me ask you another question from the audience, which is, this is for Ajay. When you say private block, does that mean you cannot use the NAT gateway for internet access? Is that what that means?
That is true. We don't have IPv6 support for NAT gateway, and the reason is because we have the GUA CIDRs or the GUA prefixes. We don't support EULA today. So that is why we don't have IPv6 support for NAT.
Yeah, and I think, Nalini, I would guess that you folks would agree that in terms of the IPv6 standard, NAT is discouraged. So our NAT gateway has a very specific function, which is that it's a many-to-one port translation that it performs for the purposes of masking private and public IPv4 addressing. So it doesn't really fit into the IPv6 story. As Ajay was explaining today, we support GUA addresses only for IPv6. Now, if we did have a case at some point where EULA, for example, was being leveraged, I suppose we could start thinking about that. But today we don't support any connectivity through NAT gateway for IPv6.
Well, and as you say, it's like the minute you mention IPv6 NAT, even more hackles go up with the nerd community. But yeah, and definitely we can discuss offline, because when you say EULA, I'm surprised we didn't get more questions about EULA, because that can be quite useful. But as I say, I don't want to. I want to let you get through your presentation. I'll just ask you one quick question, which is that again from our audience, is that IPv4 NAT still works, right?
Yeah, IPv4 NAT still works, yes.
Great.
And I'll show you how they are different in the routing tables. That was my next set of thing I wanted to show.
Perfect. Yeah. Great. Well, let me keep my mouth shut and let you get going.
No, that's totally fine. Yeah, feel free to interrupt me at any point of time. This is more of a discussion and talking IPv6, so it's okay. Feel free to bother me anytime. So the next set of P's that I wanted to actually show is the routing table entry. And as you saw that when I was creating a subnet, I had associated a route table with my subnet, which is the default route table rule. And this default route table does not have any rules by default. So the user has an option to either create as many route tables they want by clicking on create route table, or they can just go ahead and click on that and click on add route rules. So once you do add route rules, Nalini, this is something that we were talking about. So when we select, it gives you an option to a user to go with IPv4 or IPv6. But when I select IPv4, I have an option of all the gateways that we support, including the NAT gateway. So dynamic routing gateway for any communication to on-prem or to any communication between VCNs in the same region or a different region, internet gateway to communicate to the internet, local peering gateway for any communication between VCN in the same region, NAT gateway, as we all know, uh, communicate to the internet if you don't have a public IP, and private IP is if you have some sort of network virtual appliances that you want to have it as a next hop for any traffic that is coming through the DRG for the on-prem. And then service gateway, like Sharin was talking about, it's a gateway where you can access the OCI services without going to the internet. The traffic actually goes to the Oracle backbone. And then when I select IPv6, which is the topic we are talking about, we kind of filter the gateway support that we have. So as you can see here, we do not have the NAT gateway support listed here because we do not support it uh, with IPv6. And then for the demo sake, what I'll do is I'll select internet gateway, and then I want to also select the destination side block here. So uh, as you can see, I don't have an internet gateway uh, configured here. So quickly, what I'll do is I'll first create an internet gateway. I'll go back to my VCN and just click on create internet gateway, give it a name. Once that is created, I'll go back to my routing table and then select IPv6, select internet gateway, and here is where I will say allow everyone that understands or is able to talk IPv6 over the internet. So ::/0 represents that you know anything can be reached via this internet gateway that understands IPv6. And to do that, please use the internet gateway of the VCN that I just created. So feel free to interrupt me if there's any question. But in the meantime, what I'll do is I'll add this routing table rule. And then the user may also want to add a similar route table rule for v4 also, because as you know, we support dual stack. So I'll quickly do it for v4 as well and use the same internet gateway. So the user can use the same gateway for both v4 and v6, and we can have both v4 and v6 rules in the same routing table. You don't need to have a separate routing table for v4 and v6, so they can coexist in the same routing table and talk both v4 and v6. So the next set of thing that I wanted to show you is the security list. So once we create a subnet, and if I click on the subnet, by default, every subnet has a security list rule that gets created. And when you create a subnet and enable IPv6 on it, by default, we also have some security list rules for v4 and v6. So as you can see, we have some v4 rules to allow SSH traffic on port 22. And then we have this ICMP rules for packets that are like large and they need fragmentation. So similarly, just to, like Sharin mentioned, that we wanted to keep a similar experience for v4 so that when they come for v6, they have the same knobs configured the way it was for v4. So even for v4, we allow SSH traffic by default, and then the similar story for v6 for ICMP if the packet is too big. So and this is where this security list is something that configures the traffic, or like it determines. Think of it like a firewall that is configured on a subnet level, which you want to do definitely to make sure that these many protocols can be used to access your application sitting in the subnet. So this was the story I had for a VCN. And one more point I just wanted to show you is that, say for example, you did not have v6 enabled in your VCN at all, and later you decide to enable v6 in it. So that is when the user would come into this particular CIDR block section. And for this demo, I already had it enabled, but if I did not have, I would just come up here, click on the CIDR blocks, and then just click on this add IPv6 CIDR block. Now it's complaining to me because I cannot have more than one IPv6 CIDR block. And that is because I have these many IPv6 addresses that can be associated in my VCN. So I don't need to have more than one IPv6 CIDR block. This is the number which I cannot even, I don't even know how to pronounce it. So just imagine, I mean, there won't be any situation where a user would need more than these IPv6 address. So this is what I had for VCN, and I'm just checking on time. We still have a few more minutes. So what I'm going to do next is I'm going to show you how to launch a compute instance. So as you may have seen in Shireen's slide deck, there was compute instance, there were load balancers. So in the interest of time, I'll quickly first show a load balancer, how easy it is to enable V6 on a load balancer. So this is the load balancer homepage, and you will be able to see that I've already created many load balancers with this particular IPv6 enabled on it, which has IPv4 public IP address and IPv6 public IP address. And then the way to do it is you just come into load balancer, and then today we support two types of load balancers. One is the layer 7 load balancer, and the other one is the layer 4 load balancer. But today we just have IPv6 support for layer 7. We're still working on enabling it for the L4, the layer 4 LB. And then you just come on to click on to the LB, give it a name, LB, then just select the type of load balancer you want to have, and then select whether you want to have an ephemeral IP address, which is something that will go away when you delete this OCI resources, or you can just decide to use a reserved IP address, which will still remain after you delete the OCI resources, and then select the shape you want to have for the LB. And this is where you enable V6 for the LB. So just a check of a button for the load balancer, and one can easily enable V6 for the LB. So I'll go ahead and select the VCN, or I can just select the VCN demo nullity that I just configured and use the public subnet that I configured. Click on next, and I'll leave this thing as the basic options. Click on next, and then select the type of the listener I want to have it. So I'll just select quickly a simple HTTP load balancer and hit on next. And if you decide to enable logs for your LB, it gives you an option, but I don't need to do that right now. And I'll just, okay, I'll select the default. So this is how you enable V6 for a load balancer, which was very simple. And it'll take some few more minutes, but once it comes up, it will be something, it'll take that CIDR from the IPv6 prefix that we had defined on a VCN or a subnet level. Now let's see how it looks like into compute. So if I go on to compute instances, click on instances. For the sake of time, I've already created a compute instance in a subnet or in a VCN that was IPv6 enabled. And this particular subnet was also IPv6 enabled. This was done before this particular demonstration. So that is why I chose to have another VCN and subnet, which was already created. The way to enable V6 is you come down at the bottom, you click on the attached VNICs. So every compute instance has a VNIC associated to it. So when you click on this particular VNIC, and if this particular resource, when I say resource means either the VNIC or the compute, is created or launched from an IPv6 enabled subnet, you will see this option of IPv6 addresses. If it is created from a subnet that is not having IPv6 enabled, you will not see this particular option. That is one thing to note of. So the thing you would come do next is just come here, click on the assign IPv6 address, and then just click on this button. And once you do that, you can either fill in the remaining bits yourself or just decide to keep it the way it is, and we'll do it for you. And if you have another IPv6 address which is assigned to another VNIC and you want to unassign from that particular VNIC to this particular VNIC, you can also decide to do that. But I will not do that. I'll just simply click on the assign and I'll let Oracle assign a proper v6 address for me. So this is what happens. And as you can see that I assigned this v6 address after this particular compute instance was launched. So let's do one thing. Let's log into this box and see what do we see now. So I'll log into this box using the public v4 address, and I'll click a new tab. Try to zoom in a bit. So I'll use my keys to log into this box. And as you can see, if I do an ifconfig here, I don't see this IPv6 address yet. And that is because I enabled it after this particular instance was launched. So I either wait for the next DHCP v6 cycle to come in and assign it to this particular VNIC, or I can just use like a DH client to do that. So the way to do that is you use the DH client software, which is installed in the Oracle Linux box by default, and just give the interface name, in this case is ENS3. And as you can see, this is not the v6 address that we were looking for. So I'll go ahead and run this command, and it will grab that v6 address right away, or it should, hopefully, unless we are seeing any bug. So let's give it a few moments. And if it doesn't come up, I have another instance that I have already done that on. So I'll log into that piece as well. Yeah, it takes a while for the DH client to come up. So as you can see, once it successfully assigns or uses DH client, it will just give me the same IPv6 address that Oracle had assigned it to me. For some reason, it's kind of stuck here, and it always does when I'm doing a demo. I hope, let's see, is that the command? Let me quickly Google. Sharin, can you confirm that command for me?
Yeah, let me look.
Yeah, it's been a while I've configured that, but I'm sure it's something similar. Yeah, it is sudo dh client -6 interface. That is correct. I think for some reason.
Yeah, I think it's just getting.
Okay, I think that I know the reason why. It is because maybe my security lists were not yet open correctly, and that is the reason it is not working properly. You know what I mean? So what I'll do is I'll use the existing one, the other one that I have seen, and from here it's basically in the same subnet as what I was trying to create. And now what I'll do is I'll try to ping the internet using the v6 that I got. And as you can see, I was able to successfully ping the internet. using the GUI addressing that I had. And you know what? I'll also try to ping. I'll try to do some east-west, and I'll try to ping the load balancer that I just created. So I'll go on to the networking, and let's try to ping the IP address I created some time ago. So I'll just try to ping that. Okay, it's not pinging. I'll try to ping another IP address, which is in the same subnet. So the reason it was not pinging this particular IP was because it's in a different VCN and I have not done the routing. I'll try to put it. I'll try to use the same IP address. Yes. So this is the one sitting in the same VCN, and the routing has been done. So I'm able to ping the LB sitting in the same VCN. The reason it was not pinging this guy because I used a different VCN and there was no routing between the two. So with that, I think somebody had a question. Nalini, maybe it was you.
Yeah. No, I think we're getting near time to close. And so guys, do send more notes, and just because we want to start closing up. Thank you guys so much for being brave enough to present to our crew of pedantic V6 nerds. But one question that I did have that I know I hear a lot is, do you charge for IPv4 addresses?
Not today.
Not today.
So maybe tomorrow, or who knows, right?
Yeah, I can't. I'm not at liberty to say, but today we do not.
Yeah. No, I think, you know what, to be honest with you, and I don't work for Oracle, guys, but as a V6 nerd, I would love for people to start charging, because you know what, I'm telling you something. I know it's hard to do all this conversion, but people need a business reason to convert. So to be honest with you, I would be happy to see you charge, but that's Nalini's personal opinion. Take it for what it's worth.
I'm just curious, would you have the same opinion if that meant we would charge for IPv6 addresses as well?
No, I mean, I would prefer you didn't charge for V6 addresses. But having said that, I mean, there's so many more V6 addresses that are available. Right. So it's kind of got to be like apples to apples, you know what I'm saying?
Yep. I was just curious because we're having a lot of internal discussions about this. So I was just kind of curious your thoughts. So I appreciate you expressing your opinion.
Yeah, you're never gonna not have me express my opinion. No, but guys, send me any more questions that you have, and I am getting it. Just FYI, I am getting a couple of other folks saying that, in some, just as I say, not that I want to pound on the cider thing, but kind of like for our people, it is getting, it's a little, it's like we don't talk that way, but down the road, what I'm going to suggest too is I'd love for you guys to keep working with us, because we are very V6 focused and enterprise. And we're hoping to set up a standalone lab that's focused at these kind of people, the brick and mortars of the world who have very specific needs. And again, thinking because V6 offers so many advantages, is we want people not to get trapped in V4 thinking. Your subnet does not need to be 255 people, you know what I mean? Because you can have a ton more hosts. Yeah, you see what I'm saying, Shireen?
Yep, I do. I wholeheartedly agree. So what I will do, Nalini, is I'll reach out. I would love to have an offline conversation with you and whoever else you'd like to bring. We're very open. We love this kind of feedback, and yeah, we very much value it.
Perfect. Well, thank you guys again. And guys, do send me any questions or whatever. We will be making the presentation as well as the recording available. And Oracle's rules are that the presentation is available for 6 months, which is absolutely perfect. You know, thank you so much for having that. I just wanted to give our people, you know, fair warning. So do download quickly. Not that 6 months. 6 months is a bit. And I'm sure they will have moved way, you know, they're moving fast and will have added plenty of more features. So you'll need another, you know, session maybe anyway. Thank you again, Jay and Shireen, and I look forward to you guys working with us in the future.
Sounds good. Thank you so much.
Yep.
Bye.
Bye.